Alright, so we are going to continue with grade 9 and 8 geometry. And to get this session started, this is what we are going to do. We are going to do the following. We are going to do the following. Just bear with me. Just bear with me. We are going to do the following with grade 8 and 9 geometry. Here it is. This is the document that I need to locate for the purpose of doing this particular lesson. Alright, so we are smack bang looking at grade 8 and 9 geometry. We have done the first 10 theorem statements that are in this document. Now we are going to move on to the triangles. Alright, triangles are very important, and under the triangles we have a few statements that we need to be looking at. So I need you to go through this document with me. But in that document, I want you to now turn your focus to the triangle statements, the statements that have to do with triangles. The very first statement there says the interior angles of a triangle. Can we double tap on the screen, guys, so that we can get the live likes up, so that the live is visible? The interior angles of a triangle are supplementary. Is our first statement there. The interior angles of a triangle are supplementary. Right? We start right there. The interior angles of a triangle are supplementary. Next to that statement that you can see there. So for those who are joining in, welcome to the grade 9 geometry, grade 8 and 9 geometry session. We are literally looking at session 5, I believe. Okay, we are looking at the triangles. So on your screen, you are seeing it. That's the acceptable reasons Euclidean geometry document. You can see triangles. Alright, so you can see there's the heading theorem statements. Underneath there are 10 statements that are listed there. We have already covered the first 10 statements. Now we are going to triangles, and underneath triangles, the very first statement underneath triangles says the interior angles of a triangle are supplementary. Then next door to it, there are acceptable reasons that you can use whenever you are using that theorem statement. Alright, please take note of the acceptable reasons that you can use when you are using this particular statement. Okay, there's angle sum in triangle, there's sum of angles in triangle, and there's interior angles triangle. These are the reasons you can use whenever you're using the statement that says the interior angles of a triangle are supplementary. That's statement 1. Statement 2 underneath triangle says the exterior angle of a triangle All right, sorry about that, guys. Interior angle. So this interior angle. So we are now looking at the theorem statement that says the exterior angle is equal to the sum of the interior opposite angles. Okay, and if you look at the reason that they use in brackets, it's ext, which means exterior, and then the symbol of angle, and then of triangle. All right. Okay. 3. The third statement that refers to triangle says the angles opposite the equal sides in an isosceles triangle. In an isosceles triangle are equal. Again, the statement says the angles opposite the equal sides in an isosceles triangle are equal. And then in brackets there you can, your acceptable reason there that's used is angles opposite equal sides. Angles opposite equal sides. Right. Then the fourth statement we are going to look at when we are looking at triangles is the sides opposite the equal angles in an isosceles triangle. In an isosceles triangle are equal. And the reason there that they usually use is sides opposite equal angles. Okay. Then the last two that I'm just going to stop at. The fifth one says in a right angled triangle. In a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. And the acceptable reason says you can either say Pythagoras or you can say theorem of Pythagoras. That's like in full words, full complete words. Okay. And the sixth statement we are going to look at for today is the one that says if the square of the longest side, in a triangle, if the square of the longest side in a triangle is equal to the sum of the squares of the other two sides, then the triangle is right angled. And whenever that is used, we either say converse Pythagoras, or we can say the converse theorem of Pythagoras. Now guys, this document, it's very, very important, this document. I cannot overstate how important this is for any learner that is hoping to have a shot at ensuring that their geometry is on point. You have and you must master and also understand this document and what it says very well. I'm not going to remove this document because what I've done is I've looked at the first 6 statements under triangles, and now I'm going to unpack them so that we understand the meaning, the diagram, and the reason. The meaning, the diagram, and the reason. Okay, the MDR, meaning, diagram, and the reason. So let me just remove what you see in front of you so that Miss Chipmunk can do what she does best. Here we are. So grade 8 and 9 geometry. So if you are a grade 8 and 9 learner, you are in luck. If you are in grade 10, being here is not a loss. If you are in grade 11 and grade 12, being here is also not a loss, because the basics that I am going to unpack right now are so fundamental for any learner in any grade. So you have to understand these basics. So I'm going to go back to the first statement. I'm going to read the first statement because for our Euclidean geometry session today, we are looking specifically at the theorems that have to do with triangles. So the first one says, the interior angles, by interior we mean what? We mean inside. So the inside angles of a triangle, what is a triangle? A triangle is a three-sided shape, a closed three-sided shape. So the interior angle of a triangle are supplementary. What does supplementary mean? It means that those angles inside a triangle, they all add up to 180 degrees. So what you need to then visualize in your head is this triangle. Let's just say it's triangle ABC. Therefore, this statement, what is it saying? It says the interior angle of a triangle are supplementary. The inside angles of a triangle are supplementary. The question is, how many inside angles does a triangle have? How many angles does a triangle have? So hopefully, I hope you guys can see there's this angle 1, that angle 2, and then that angle 3. So in total, we have how many angles? 3 angles. And this statement is saying that the interior angles, meaning the angles inside of a triangle, are what? They are supplementary. In other words, what does supplementary mean? We did say that supplementary simply means they add up to 180 degrees. That's the sum of the angles of a triangle. So we can say angle A plus angle B plus angle C is equal to what? 180 degrees. This is a statement that we can express mathematically to indicate the veracity, the authenticity, the credibility, okay, of this statement here. the interior angles of a triangle are supplementary, meaning they add up to 180. We can say angle A plus angle B plus angle C is equal to 180 degrees. Now, this statement needs to always be accompanied by a reason. What is our reason? You have one of three ways to state your reason. You can either say angle sum in triangle. This would be acceptable. So after writing your statement, you write your reason, angle sum in triangle. Or you can say sum of angles in triangle. Please take note, guys, of the specific notation. Could say int, in other words, this int means interior. Okay, this sum symbol means angles, and then you write the symbol of triangle. So this is one of three ways of stating the reason. Then with the and appropriate reason, and these are reasons acceptable. I have just and I posted. I hope we are together here. If all is well, please indicate in the comment section so I can move on to the second statement. If things are not all well, then I expect you to comment in the comment section that you need me to explain something because there's something that you don't understand. Failing which, if there's silence, silence means consent. So I'm going to move on. So what are people saying? Are we together? Are we lost? Further explanation? Is the theorem statement clear? The interior angles of a triangle are supplementary, meaning angle A, angle B, angle C, all three angles should add up to 180 degrees. Our reason, we can write one of three of these reasons. We could write this one, we could write that one, or we could write this one. Okay. All right. No one is saying anything, so I don't know. It's either I am a really terrible teacher and people are just not hearing me at all, or it must mean I am a very good one and I'm explaining things very well that people are simply speechless. So I don't know what's happening, but I'm just going to assume that silence means consent. So I'm going to move to the second statement. The second statement says, the exterior, thank you Tseho. It helps when people comment in the comment section, otherwise I'll never know if people are with me or not. So thank you so much Tseho for at least clarifying that you are with me and you hear me. Cool, so thank you so much as well, really appreciate it. And thank you guys for the follow. I can see the follows coming on there, also for the double taps there. Liking the live, it helps because obviously it gets the visibility of the live up there, and hopefully we can attract people that can come through that really need sessions like this, and are preparing, and some of you I know getting the terms work early in so that you can be ahead of everybody else come term 3 when it begins next week. Statement number 2. The exterior angle of a triangle is equal. Now, here's a word. The exterior. This word exterior means outside. Interior means inside, but exterior means outside. Okay, the prefix in English, ext, means outside. So the exterior angle of a triangle is equal to the sum of the interior opposite angles. So let us visualize what we mean by this. Here's a triangle, okay, and then in line with the side of the triangle, we can see that outside is an exterior angle. So let's just say this is A, B, C. Okay. A, B, C. Now, out here is an exterior angle. Something important here is that the exterior angle that you're talking about here needs to be in line. And I want to explain that because we must not think that it is any outside angle. It is an exterior angle that needs to be in line with the side of a triangle. So we need to always check and verify if this exterior angle is in line with the side of the triangle, because the exterior angle they talk about here, that is equal to the sum of the interior opposite angles, is an exterior angle that is in line with the side of a triangle. So if you look at angle C1, it truly is in line with which side? It's in line with side AC. It's in the same straight line. Okay? So it must be in the same straight line as the side in order to qualify as an exterior angle. So what is the statement we can write from this? We can say angle C1, which is the exterior angle. What did the statement say? The exterior angle of a triangle is equal, so it's equal, there's the equal sign, to the sum. What does sum mean? It means plus, to the sum of what? Of the interior opposite angles. Now what are these interior opposite angles? The interior opposite angles in this situation are angle A and angle B. Please take note. So therefore I say angle A plus angle B. Okay. Now someone else might ask, sir, can't we say angle C1 is equal to angle A plus this angle? And the answer is no. Someone else might ask, so can't we say angle C1 is equal to angle B and angle C? And the answer is no. So the only angles that are these interior angles that they are talking about for this diagram is angle A and angle B. The exterior angle, as it says, is equal to the sum of the interior opposite angles. Okay. So the way I like to think of it is, if you look at C1, you come inside, you have angle C. That means angle C is not going to be part of the sum of the two interior opposite angles. It means it's the other ones, meaning angle A plus angle B. Okay, and what would be the reason? The reason is here, x angle of triangle. So all you write is x angle of triangle. That's what you do whenever you use this statement. This is your reasoning. Exterior angle of triangle. I just want to draw a different diagram so that I can see if you guys get it here. Let's say that's DEF, and let's just say that is T. Right? So if you look at this diagram, okay, which angle is the exterior angle here? The exterior angle is angle which one? Can someone tell me? Is there an exterior angle? Let's start there first. Is there an exterior angle in this diagram, and what is that exterior angle called? Question 1, is there an exterior angle? If there is, what is that exterior angle called? If I name it, what's the name of that exterior angle? I'm waiting for people to assist me there. I need big assistance there. The sooner I get it, the better. Question is there an exterior angle? What is the name of the exterior angle in this diagram? Okay, Yanelisa says yes. What is the name of the exterior angle? How would you name it? It's angle what? Angle F2. Now the thing is, Yanelisa, you can't say it's F2 because in the diagram there is no 2. For instance, the diagram itself must have that in order for you it is. Okay, so you can't say it's F2 when in the diagram there is no 2. Here in this diagram we could say angle C1 because the 1 was in the diagram. That's very important for you to note. So I want you guys to really get that into that space that is your gray matter, so that you don't see yourself or find yourself getting penalized unnecessarily. Okay, see, someone else says angle F. Now, can we say the exterior angle is angle F? Can we really say that? That's my question. Because I'll tell you this, F is here, and angle F is kind of everything. It's you know, F obviously is here everywhere. We can't say that is F. We can't say the exterior angle is F. We can't. Torah says angle T. No, angle T is the extension of side EF, and T is a point that basically connects EF and T. So we can't say angle T. CISO says DFT. Now I love what CISO is saying there. DFT. And of course, CISO, I'm hoping that when you write that DFT, you place the correct notation so that it is an angle. So CISO, I am with you. Angle DFT. DFT. Very true, CISO, with a cap on top of F. Okay, thank you so much, CISO. CISO, I winner. CISO, I need to just give a sweet one. CISO is a very woke learner there. Okay, very, very woke. All right, very, very woke learner, that one. So we can either say that exterior angle is DF, middle letter T, the cap on top of T, or we could say what? Angle DFT. We could say it, we could write angle, then say DFT. Or we could say it's angle TFD, going in this direction, TFD. Or we could say angle TFD. Okay, this is something that I did in my introduction videos on geometry for grade 8 and 9. The videos that I'm talking about are already uploaded onto my YouTube channel. You can find the link in my bio. All live lessons that I do are uploaded onto my YouTube channel. The YouTube channel, the link is in my bio. You can please go and visit it so that you can watch some of the geometry lessons that I've done so far, okay, for grade 8 and 9. This is foundation geometry for grade 10, 11, and 12 as well. But primarily, I'm doing this for the grade 8s and 9s because term 3, they are doing this. 10, 11, and 12, you guys are supposed to know this, okay? So when we say angle DFT, or angle TFD if you want, that is our exterior angle. This exterior angle, what is it equal to according to the statement? The exterior angle of a triangle is equal to the what? To the sum of the interior opposite angles. Now I need to know from you, it's equal to what? Angle DFT. What are my two interior opposite angles? The sum of the two interior opposite angles. Which ones am I talking about? You can write in the comment section and you can add those two that you are talking about. What are the two interior opposite angles we are talking about? Whose sum gives me my exterior? And Elisa says D and E. Torah says D and E. CISO says D plus E. Alright, we've got it down, guys. Angle D plus angle E. Now we could speak about angle D in isolation, and we can speak about angle E in isolation, because there's no other angle around that would basically make us say, but is that really angle D? Is that really angle E? It is, because it's only angle D and it's only angle E. It's a very different story about this part where I was like, what angle can we say the exterior is? And then you say to me angle F. We can't say this is angle F. Remember, F as a point here has this angle. The entire angle is F, right? So that's why we need to be careful, all right? We use our letters to be able to refer to the specific angle if it is not been specified, so that we can keep the integrity of the theorem statement. The exterior angle of a triangle is equal to the sum of the interior opposite angles. Then after we write the statement, what would be our reason? We would write this reason: exterior angle of triangle. Okay, we do not forget the reason, because without the reason, then our statement is not complete if it is not accompanied by the reason. Okay, how blessed we are. We are joined by Mr. Euclidean. What are the chances? We are busy with geometry and Mr. Euclidean decides to join us. How blessed we are. Okay, I think that is an indication that all of us in this life, we are really going to make it. Okay, all right. Now I want to ask this question. If I draw this diagram, do I have an exterior angle here? And first and foremost, Yanelisa says, no, you don't. What does everybody else say? Is there an exterior angle? Or asked in another way, is it the exterior angle for this particular theorem? Okay, if there is an exterior angle, okay, let me just ask simply, do I have an exterior angle in this diagram, in this triangle? Let's start there. Do I have an exterior angle for this triangle STR? Is there an exterior angle? Okay, Yanelisa says, no, you don't. Tora says, I think you do. So Taurus is not sure. Yanelisa says exterior angle is an exterior angle due to a straight line subtended. Yay! Hey, Yanelisa Njili. You don't mess around with Njili there, hey? Njili is Njillaring, hey? Don't mess with Njili there, hey? Wow, hey? Siso is like not for this. Okay, guys, thank you so much for all your comments, and I really appreciate them. Okay, I love it when people engage with me and they don't just listen to me and, you know, I don't know, like, it worries me when people just listen and there's no comment, no nothing, no interaction, you know, gives me a very weird feeling. So this triangle STR has an exterior angle. Okay, the exterior angle that exists is angle SRP. Angle SRP is called an exterior angle. It is, because it is an angle that is outside the triangle. But if I'm going to ask this question, is this exterior angle the same exterior angle that we talk about in this theorem? That is the question I'm asking. Is this exterior angle the same exterior angle for this theorem? The exterior angle of a triangle, which is equal to the sum of the interior opposite angles. Is this exterior angle the one? You can answer that question now. Okay, so we've established one, that this is an exterior angle because it's an angle that is outside of a triangle. That we cannot deny. But what I'm asking now is this exterior angle the same exterior angle of a triangle, which is equal to the sum of the interior opposite angles? Is this the angle that we are talking about? Could we properly say that this exterior angle is that exterior angle for this theorem? Is it? The exterior angle, which is equal to the sum of the two interior opposite angles, is this angle the one? If you say it is, why? If you say it is not, why? That is what I need you to answer for me. So torus is saying no because it's not opposite to those two angles. Okay, torus, I hear what you are saying. Okay, and Yanelisa says no because the sum of the two opposite angles might not be equal to the exterior angle. Okay, torus, I hear you. I mean, Jilly, sorry, Yanelisa, I hear you as well. All right. So let's go back to what I had said when we started with this theorem. We said the exterior angle of a triangle is equal to the sum of the interior opposite angle. It cannot, because given enough information we can prove that it is equal to S. Okay, yeah, but see, so be very careful as well with that statement that you are saying, all right? Because this exterior angle may not necessarily be equal to angle S, because you know nothing has been said about this line and this line being parallel. Okay, so let's be careful even about that, because it would need additional information. Okay, so we can't really conclude that that is the case. But I think from what you have said in the comment section, we know that the exterior angle, this exterior angle needs to be in line with the side of the triangle. So my question is TR extending to P in the same line? Okay. Yes, Yanelisa, I agree with you. I agree with what you just said. If there were parallel lines, that would be true, but that has not been told to us. So is TR in the same line as P? That's the question. Okay, is TR in the same line as P? Okay, because remember, what did we say? This exterior angle needs to be in line with the side of the triangle. Is RP in line with the side of TR, the side of the triangle? And the answer is no. Okay, so this angle is not the one that we say is the exterior angle equal to the sum of the two interior opposite angles. It can't be. Why? Because it's not in line with TR. It's not in the same line as TR. Okay? Does that make sense? All right? I hope that makes so much sense, guys, because you need to understand that the exterior angle we're talking about here for this statement needs to be in line with the side of the triangle. Hence, when I started and I introduced the theorem, I explained what the exterior angle we are talking about, what it is. So now that you know, I hope you know, and you will never forget. That is why this diagram, we could clean say angle C1 is equal to angle A plus angle B, because C1 is in line with the side of the triangle, no problem. And that's our reason. Angle C1 is equal to angle A plus angle B, no problem. This diagram, remember this one, we said angle DFT is exterior. Why? Because it's in line with the side of the triangle. EF extends to T in the same line. Therefore, we can say angle DFT is equal to angle D plus angle E. Reason? Same reason. Exterior angle of triangle. No problem. But here, we run into a problem. Okay? PYT, I'm busy with grade 8 and 9. What are you talking about now? Okay? Yeah, this is grade 8 and 9. Alright, please, people, anyone who's joining in, this is grade 8 and 9 geometry that I'm doing for triangles. Right? And those who are here, okay, this is probably it's a 5th session in Euclidean geometry for grade 8 and 9 that I'm doing today. You know, we've done lines already, parallel lines, and we've done problems, and all of the lessons and the sessions I've done are uploaded onto my YouTube channel. You can go to the link in my bio, go there, go to the link in my bio. There's a grade 8 and 9 geometry playlist that is there, and I've uploaded 4, I think, parts, you know, of the geometry already. Parallel lines was uploaded to yesterday as well, so there's also geometry in there of parallel lines with, you know, problems that we did yesterday. Today I'm starting with triangles. Okay, so this is very important that you, for this triangle, you would say angle C1 is equal to angle A plus angle B, because that's what applies when we apply the exterior angle of a triangle being equal to the sum of the interior opposite angles. So here I'm still looking at the various theorems, statements, and axioms that we use in grade 8 and 9. So you guys just need to be patient, because we are going to go into problems. For now, I need you to understand what the theorem statements mean, how they then apply for a diagram, and the reason that we write for each statement. So let's move on to the third statement for triangles. All right, everything else, lines, parallel lines, you can find in my YouTube channel. The link is in my bio. As I said, you can watch those videos, good wholesome videos where I interact with learners on TikTok live with this content. 3, the angles opposite the equal sides in an isosceles triangle. Isosceles triangle. Isosceles triangle. The what? The angles opposite the equal sides in an isosceles triangle are what? Are equal. Okay, and the reason we use is angles op equal sides. So if we look at a specific diagram, we would have triangle ABC. So we could say here angle B is equal to angle C. All right, why? Because the angles that you've just identified are opposite, op equal sides, and the sides that are equal have already been marked. It's AB and AC. So we say angle B is equal to angle C. This angle is equal to that angle. What is our reason? Angles opposite equal sides. That would be our reason for saying that. So I want to read the statement again. The angles opposite the what? The equal sides in an isosceles triangle. An isosceles triangle is a triangle that has two sides that are equal. All right? Are what? Are equal. So you can see AB is opposite angle C, whereas side AC is opposite angle B. So that's why we say angle B is equal to angle C. The reason is angles opposite equal sides. I think that's pretty straightforward. It needs no further explanation. I'm going to move on to the next statement. The sides opposite the equal angles in an isosceles triangle are equal. So let's look at a diagram here. That's 45 degrees, that's 45 degrees. We have a triangle DEF. You guys can clearly see that angle E and angle F are 45 degrees. So we can say the following. DE is equal to DF. Why? The sides are opposite equal angles. Right? So I can say DE is equal to DF. Why? Because DE, which is opposite 45 degrees, and DF, which is opposite this 45 degrees, are basically sides that would be equal. Why? Because these two sides are opposite angles that are actually what? That are actually equal. So DE is equal to DF. Please take note, sides opposite equal angles. So you could say it's the reverse of this. Okay, this one had said if this and that are equal, then angle B is equal to angle C. What was the reason? Angles opposite equal sides. But all of a sudden, if it's the angles that are equal, then it would serve that the sides are equal, that are opposite the angles. So that's why we say sides opposite equal angles. DE is equal to DF. Okay, moving right along. The second last statement that we need to know. In a right-angled triangle. What type of triangle? In a right-angled triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. I repeat, in a right-angled triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. I think one more time, I will repeat. What do you guys think? In a right-angled triangle, I usually call a right-angled triangle, look at the first letters, R-A-T. So I call a right-angled triangle a R-A-T. I call it a rat. In a right-angled triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. Right angle triangle loaded, A, B, C. Right angle means a right angled triangle. So there's an angle that's 90 degrees. The angle 90 degrees is always opposite what we call the hypotenuse. The hypotenuse is the longest side of the triangle. The longest. Okay? Which means these two sides will never be longer than the hypotenuse side, because hypotenuse is the longest side. Okay? And the hypotenuse is always opposite the 90-degree angle. Always. So what does this theorem statement say? It says in a right angle triangle, the square, so AC, the side squared, is equal to the sum. Sum means plus. Okay? Okay? Sum means plus. So it's equal to the sum of the square of the other two sides. What's the other two sides? We have AB, so that means we're going to write AB squared. And the other side is BC. BC squared. Okay, I think we may have lost each other in this live. I was asking what is the longest side in this triangle. This statement says if the square of the longest side in a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right angle triangle. So if we look at this triangle, what side is the longest in this triangle? Oh, so here in this live, it's just people, it's not grade 8s and 9s that are here. It's like university students, because people here are speaking about in civil, we use it to determine heights. All right, at least you guys are giving the kids some hope, because I'm sure these kids, they do all of these things and they have no practical application in any real life scenarios, and they ask themselves, when will I ever use these Pythagoras calculations, and where will they ever have relevance in the life I'm yet to live? So you guys are giving the kids some hope, which is good. Okay, so let me just take care of this. So in this triangle ABC, to prove that triangle ABC is a right angle triangle, we go back to the statement. It says if the square of the longest side in a triangle, so the square of the longest side, we take AC alone, it is equal to 5. So what we are going to do is we are going to square it. When we square 5, we get 25. So that is the square of the longest side. It's equal to 25. So the statement is saying if the square of the longest side in a triangle is equal to the sum of the squares of the other two sides. Now let's go and take the other two sides, which are not the longest. So we have AB plus what? Plus BC. And what we are going to do is we are going to square these two. So AB squared, that means 4 squared plus what? Plus 3 squared. Now 4 squared is equal to 16. Four squared is equal to 16. 3 squared is equal to 9. 16 plus 9 is also 25. Remember, when I squared the longest side, I got 25. The sum of the squares of the other two sides is also giving me what? 25. So I think I can conclude here that AC squared, which was 25, is actually equal to what? To AB squared plus what? Plus BC squared. Therefore, 25 is equal to 25. Triangle ABC is a what? A right angled triangle. What is the reason? Converse Pythagoras. So this would be a typical example of me proving that triangle ABC is a right angle triangle. Okay, so that's a practical example of how you would have a situation where you would have to use this scenario number 6. Okay, I hope that's clear. I hope that's clear for you. Okay. I really hope that's clear for you guys. Any questions? Okay, now let's look at some examples so that we can apply. Okay. So we have triangle BAD, that is X, that is 40, that is 80. Okay, that is 80, that is 40, that is x. And what they are saying here is they're saying determine x, give reasons. So guys, let me see. What do you guys think? Determine x, give reasons. So what would we say here? Remember, first and foremost, we need to give a statement and a reason, and then that's important so that we can get the value of x for the angle. So how would we start or kick off this question? Okay, so we have angle AB, which is 40, angle A, which is x, angle D, which is 80 degrees. So remember, these are three angles inside of a triangle. So if we go back to what we had learned earlier on, we had learned that the interior angles of a triangle are what? Are supplementary. In other words, they what? They add up to 180. Okay, so what can we do with the three triangles that we have been given, knowing that two of them we know, just at the last one we don't know? We can write a statement. Which statement says what? We can say the following: 40 degrees, which is B, plus x, which is A, plus 80 degrees, which is angle D, is equal to 180 degrees. And then what would be our reason for saying that? We can say one of three things. We can either say angle sum in triangle, we can say sum of angles in triangle, or int angles of triangle. So I'm just going to say angle sum in triangle. I mean, you are more than welcome to use any one of these three, as long as it is any one of these three. So I use angle sum in a triangle, and then after that I solve the equation on the left hand side. So I would practically get, guys, and this is the mark allocation, you get a mark for the statement and you get a mark for the reason. Then you solve. X, you isolate on the left, you transpose all the numbers. And remember, when you transpose numbers in an equation, the 80, when it crosses over, becomes negative 80 degrees. The 40, when it crosses over, becomes negative 40 degrees. And then after that, you add and subtract the numbers. What's 180 minus 80? It's 100. What's 100 minus 40? It's 60 degrees. So x is equal to what? 60 degrees. You get a final mark for your calculation. And that is basically how you would go about answering that question. Okay. Any questions? Okay, does it sound straightforward, guys? Can I move on to the next one? Are you ready for the next? And the next? And the next? Any questions? Any questions at all, guys? Any questions at all? Me is here to help you. If you don't use the opportunity that is now available to you to ask me any questions, then I don't know, guys, what you want from me. Me, I'm just trying to help you. And I'm helping you for free here. You know? All you need to do is sacrifice your time, and then when you are lost, you ask me questions. I'm not asking for anything. Yes, for the reason. What do you mean for the reason what? Sometimes. 40 plus x plus 8 is your statement. Is equal to 180. Because sum of angles in a triangle gives you 180 degrees. And I said you can use one of three of these reasons. You can either use angle sum in triangle, that's acceptable, Or you can use sum of angles in triangle. I could have written here in this bracket sum of angles in triangle if I wanted to, instead of writing angle sum in triangle. Or you could write int, which means interior angles triangle. Okay. I usually suggest to a grade 8 and 9 learner that choose one reason and stick to it forever. Choose one reason and use it consistently throughout your high school career so that you don't deviate. Choose one and use it forever. When you choose one and use it forever, then you know that you are always on point. So remember, for the interior angles of a triangle are supplementary, in other words, add up to 180 degrees. We know that all three angles in a triangle will add up to 180 degrees, and that's why we say angle A plus angle B plus angle C is equal to 180. And our reason must be written immediately after the statement, so it's one of three of these. You choose one and you stick to it. That's my suggestion to you. Okay. Any further questions? Any further questions? Anything at all? Okay, here's another one. Anyone who has the answer for this? Here's a triangle. We're given 1, 2, 3. These mean something, obviously. What is the value of x? Anyone know? What is the value of x? How would we go about calculating that? Anyone? Okay, so this value, so this A is equal to x. This D, so angle A is equal to angle B is equal to angle D. All right, I'm sure you can see why. And it's all equal to x. The reason is equilateral triangle. Okay. Angle A is equal to angle B is equal to angle D. You see these sides are all equal, and therefore all angles would be equal to x. That's equilateral triangle. But remember, we want to determine x giving reasons. So if all three angles are equal to x, then it means that we can say x plus x plus x is equal to 180 degrees. What's the reason? Once again, angle sum in triangle. So what's x plus x plus x? That gives us 3x. And that's all equal to what? 280 degrees. Okay, then now we can solve for x. That means 3x. We divide both sides by the coefficient of x, which is 3. What we do on the left, we definitely must do on the right. Therefore, our value of x is equal to 60 degrees. And there it is. Okay, that wasn't too bad, was it? Okay, right? So, very, very important here. Okay, yeah. So if we look at this mark allocation, okay, looking good, looking fresh. I hope so. Okay, I think we can move on to the next one. Okay, here's another one. That's the diagram. And here we are being asked once again to determine the value of x. Okay, determine the value of x giving reasons. Confidence in all, look at that. Saying angle A plus angle B is equal to x. Okay, what's the reason? Confidence in all. Okay, that's a true statement. I agree with it. Angle A plus angle B is equal to x. Okay, I agree. So in other words, what you're saying is 43 degrees plus 73 degrees is equal to x. Okay, and then okuhle ox is saying exterior angles. Okay, yeah, so let's take note that we remember what we said. We said the exterior angle of a triangle, and by exterior angle we mean the exterior angle needs to be in line with the side of the triangle. So what we can see here is that BC is in line, okay, with the exterior. Okay, so it's with the side of the triangle that this extension is there, and the angle that is external is exactly in line with the side. So that is true. It is the right exterior angle. So we can say x is equal to the addition of the two interior opposite angles. So 43 degrees plus 73 degrees is equal to x. That's very true. What is the reason? Let's not forget that according to the acceptable reason document, we write ext angle of triangle. Please guys, exterior we write ext, angle the symbol, of we write off, triangle the symbol of triangle, we close the bracket. So that is 43 degrees plus 73 degrees is equal to x. Reason, exterior x angle of triangle. Okay. Guys, statement, reason. You see, I hope we see there, and I hope we are very clear there. Okay, that was just to support what had been said, but to be specific, I just go ahead and substitute 43 degrees by 73 is equal to x, exterior angle of triangle, and then I solve. What's 43 plus 73? Therefore, x, this is like me putting my pen like this. If I just simply switch it around like this, right, the x that was this side, if I simply just turn this around and put it like this, the x that was this side is there. And then 43 plus 73, what's 43 plus 73, guys? I mean plus 73 plus 43, sorry. 73 plus 43 is equal to 116 degrees. Okay, so that's the value of x, and my answer is 100% correct. Okay. Are we together, guys? Okay, I hope we are. I hope we are. So one problem involving this in sum of angles in a triangle. One problem that involved sum of angles in a triangle. Another one which also did involve sum of angles of triangle, but with just a little bit of work that needs to be done first, where we can see that all angles are equal in that triangle because it's an equilateral triangle. Then adding all the x values, equating them to 180 for that reason, and then solving for x, we get x is 60 degrees. Then this problem here, we could clearly see that this is a situation of what? Of exterior angle of a triangle is equal to the what? To the sum of the interior opposite angles of a triangle. That is not to discount those who may have thought to themselves, I see that this is a triangle. So they find angle BCA using sum of angles in a triangle. And after finding this angle, they use angles in a straight line to find the value of x. That would also work as well. You'd still get x either way, all right? But of course, exterior angle in this situation is very quick and straightforward because you can see that this is an exterior angle because it's in line with the side of the triangle, and these are the two interior opposite angles. So the sum of them should give you the exterior angle, which is 116 degrees. Let us look at another. Okay, here's another one. Sorry guys for that. Let me probably just redraw this again because I don't want for there to be confusion because of the drawing. Okay, I'm butchering all these drawings. Okay, there we have it. Once again, we want the value of x. Where do I begin? Okay, I have triangle ABC. That's 90 degrees. This side is 7 centimeters. This side is also 7 centimeters. So I want the value of what? The value of x. Where do I begin? What do you guys think in the comment section? What do you think, chat? Thank you for the follows, guys. Hey, the followers are coming in strong and fast. So, what's the value of x, guys? Or how do I go about finding the value of x? I'm not asking you for the value, I'm asking you how am I going to approach this question. Okay, so let's look at it. This is triangle ABC. What do we notice about it? AC is the same length as BC. So that means these two sides are what? They are equal. So if the two sides are equal, guys, what does that mean? Right, I hope you guys can see what I mean by this. If these two sides, AC and BC, are equal, what does it mean? It means angle B is equal to angle A and they are both equal to x. I repeat, angle A is equal to angle B, which is equal to the value or the variable x. Okay, what's the reason? I hope you guys can see the reason. Do you see what the reason is? Can you state the reason in the comment section for me so that I can write it out so that all of us can see it? Why is angle A equal to angle B equal to the variable x? Why? Why is angle A equal to angle B equal to the variable x? Given that this triangle has AC, which is 7 centimeters, and BC being 7 centimeters, why can I then say this angle is equal to that angle? Okay. So we go back to our statements, guys, right? And if you remember our statements, we said the angles opposite the equal sides in an isosceles triangle are equal. So if these two sides are equal, what can we conclude about the angles that are opposite these two sides? We can conclude that the angles that are opposite these two sides are actually also equal. So we can say angle B is equal to angle C. Reason: angles opposite equal sides. So that's the reason. Angles opposite equal sides. So let's go there and write angles opposite equal sides. Okay, right, that was not too bad, was it now? Angles opposite equal sides. So whenever I have an isosceles triangle, guys, and I have the two sides being equal, it means that the angles that are opposite those two sides that are equal are actually also what? Equal. Okay, so I know in my diagram I'm supposed to have x there. That's what I'm supposed to have. Then from there, okay, statement correct, reason correct, but I still haven't found what x is. So what am I going to do now that I have two x's and 190? And I can say x plus 90 degrees is equal to what? 180. What's the reason? Why is x plus 90 equal to 180? All right, once again, we go back to your statement. The interior angles of a triangle are what? Are supplementary, meaning they do what? They add up to 180. So what am I going to do? I'm going to write the acceptable reason as I see it from that document that I started off with in the beginning. One of these three reasons are acceptable, nothing else. You don't write a remix of your own reason. You don't add spices to it. You write one of the three. So the one that I've grown to love is this one, angle sum in triangle. All right, so I'm going to write angle sum in triangle. Okay, and there it is. Then I solve. X plus x is 2x. 180, I take the 90 over to the other side, minus 90 degrees. So then 2x is equal to 180 minus 90 gives me 90 degrees. Then I solve for x. Divide both sides by 2. X is equal to 45 degrees. Statement, reason, answer. Okay, and the working out 100% on point. Solving the equation like a pro. Okay, solving the equation like a pro. To answer the questions that are listed in the comment section, no, I don't offer maths lit, and no, I'm not going to be doing science. I do maths purely. The channel itself, guys, says maths is a game, right? I hope that answers and clarifies any other questions people may have. All right, let's go on and let's see if we can have one other example. Okay. Okay, in this problem, we have asked to find the values of x, y, and z. Okay, x, y, and z. So, where do we start, guys? Right, is there anything that people can see? Maybe something that we can get from the get-go? We are asked to find x, y, and z. So, what are your thoughts, guys? This is A, B, C, and then there's P there. This is x, which is the length. This is z, the angle, and then this is y, another angle. Okay, and we're supposed to find x, y, and z, and this AC is 3 centimeters. Okay, so what are our thoughts? Okay, Fancy and Almighty are saying we can start with y. Cloudy says y 150, y and y50 are on a straight line. So Linati Mtuzula says, I think y is 30 degrees angles in a straight line. Okay, let's start with y. Alright, so depending on who you are as a learner, I can see some people are saying start with y. That will depend on who you are as a learner. So let's say you are the learner that starts with y. Then, if you are going to start with y as that learner that you are, yes, you are going to say y plus 150 degrees is equal to 180 degrees. Y plus 150 degrees is equal to 180 degrees. Okay? The reason, very important, angles on a straight line. Please, guys, acceptable reason document that we have all concluded about angles. The symbol on a, STR for short, line. Y plus 150 is equal to 180. Then you solve for y. Our y value is equal to 30 degrees. I have no problem with that. Our value for y, we have gotten it. Okay. So my mark allocation, statement, reason, answer. Now I have y. I fill it in. Okay. Then there was someone who commented in the comment section and said, Cloudy06006 says, and I pin his comment, when you have found y and 30, y is 30, you can find z with a sum of angles in a triangle. So if I have 30 degrees here, guys, Cloudy006 is saying I can then use the 30 and this 30 and get z using sum of angles in a triangle. So let's apply what Cloudy has just said. Okay, Cloudy, I've acknowledged what you said in the comment section. Sum of angles in a triangle, there we have it. So we are going to write down what? Z plus 30 degrees, the 30 degrees that's here, plus 30 degrees for y. Okay, this is in triangle ABC. So it's always nice to show the teacher that, teacher, I'm working now in triangle ABC. Z plus 30 is equal to 180 degrees. What's the reason? Angle sum in triangle, right? Please, guys, you make sure you use the correct reason. We have one of 3 reasons. There we have it. Okay, angle sum in triangle, or you can use sum of angles in a triangle, or you can use interior angles of triangle. So there we have it. Z plus 30 is equal to 180, angle sum in triangle. Let's solve. Z is equal to 180 minus, now this 30 plus 30 is 60, you transpose it, it's 180 minus 60, so Z is equal to 120 degrees. Okay, tick, tick, tick. Okay, now guys, this here is Z is equal to 120. Fancy in the comment section says we can also use the exterior angle to find Z. Definitely we could have. Someone else who is looking at this problem without having found y the way that you guys did could have used exterior angle of triangle. This is an exterior angle 150, and you know that it is equal to the sum of these two. So we could have said z plus 30 is equal to 150 and say exterior angle of a triangle and get what z is, which would have been 120. That would have been perfectly fine as well to find z immediately. Okay, so you see there's many ways to go about finding our values. It depends on the knowledge that we have. So if we have enough knowledge, enough geometry knowledge, okay, that's why that acceptable reason document is important. And that is why you need to have an overall understanding of all the theorems that relate to triangles, because when you do, then it's easy to find things. Okay. Now, Vogala, to all those who have been saying, we use the sine rule, Remember, guys, this is a grade 8 and 9 class. If you're in grade 8 and 9, you know nothing about sine rule, you know nothing about area rule. This is grade 8 and 9 that we are actually doing here. So, of course, if you're in another grade, you could definitely use the sine rule to be able to find the missing side x. But what would we use with the knowledge that we have as grade 8 and 9 learners? Okay, I hope you guys can see what we could do, because remember we said y is equal to what? 30 degrees. This is equal to 30, this is equal to 30. My question is, what type of triangle is that? If this is 30 and that is 30, what type of triangle do we have here? Okay, what type of triangle, and therefore what would the value of x be knowing that? Okay, Vogala 016, very true. It is an isosceles triangle. All right, I want to return you back to the statements that we had written that are found in the acceptable reason document. This one says the sides opposite the equal angles in an isosceles triangle are equal. I repeat, the sides opposite the equal angles in an isosceles triangle are equal. So whenever we have two angles that are equal, we can conclude that the sides opposite these equal angles are sort of equal. So we can say DE is equal to DF because why? Sides opposite equal angles. Please guys, this is a reason that you need to know. Sides opposite equal angles. So we can then say here AB is equal to AC, which is equal to x, which is equal to 3 centimeters. AB is equal to AC, which is equal to x, which is equal to 3 centimeters. What's the reason? Sides opposite equal angles. Done. No sine rule needed at all, because I am in grade 8 and 9. I don't know what you're talking about when you're saying sine rule and other rules. Okay, so yeah, that is it. Okay, very well done. That wasn't too bad now, was it? Okay, not too bad at all, eh? I sure hope not. I sure hope not. I really sure hope not. Okay, so I'm now going to leave this live, but before I do, I'm just going to leave you guys with 2 game challenges, because this is maths as a game. So for any grade 8 and 9 learner, okay, these are game challenges that you can attempt and do so that you can check that there's been a grasp of the knowledge. So you guys will go ahead and do the following. Determine the values of x, y, z, and t. So just look at the diagrams and you'll determine the values that are missing. So I'm just gonna draw the diagrams. Your objective is to find these letters that are small letters, not the capital letters, but the small letters. So in this problem, for instance, you need to find X and Y, right, in that diagram. That's 1. 2, this one, 100 degrees. That's DEF. That's X and Y. Then 3. This is DBC, and then A. 4. Triangle there. We have 6x minus 15 degrees there on the outside. 3x and 2x plus 12. And I think I'll leave it there for today. Actually, no, let's do this last one, 5. Yeah, so 1, 2, don't forget to give reasons for the problems. Okay guys, I am going to call it a night here for grade 8 and 9s. Thank you so much for joining in. So I will be saving this particular live video. I will upload it onto my YouTube channel during the course of this morning sometime, so that it will be available for people to go and watch on their own time. Please guys, go to my YouTube channel, go and subscribe. There is the link in my bio that you can actually find the link to the channel. Parts 1, 2, 3, 4, 5, I believe, of the live sessions that I've done for grade 8 and 9 for Euclidean geometry are already there, so people can catch up on everything else that I've done, so that you guys can be in the best place to tackle term 3, grade 8 and 9s for your Euclidean geometry, for your geometry in term 3. All right, because I've made it very simple and I've been unpacking certain things, even for grade 9s that are intending to do maths in grade 10 next year. If you're going to do pure maths and not maths literacy, you know, already I'm setting you up guys very nicely, so that you know the right reasons to use, the acceptable reasons according to the acceptable reason document, not just free-styled reasons, because free-styled reasons don't hold in grade 10, 11, and 12. So let's get it. Thank you so much for joining in. Thank you for those that were here. Thank you for those that participated. Thank you for those who double tapped on the screen. We had 4.1k likes. Yeah guys, the tapping is very, must say, you guys don't tap too much. Imagine being here an hour and the taps are so low, you know, the visibility of the live, so that other people can have the opportunity of seeing this live and joining in, very limited. Then of course I appreciate the generosity from some of you. I would say thank you for the gifts, but none were given, so I will not say that, but thank you for joining in and thank you for being here. I hope you guys have a wonderful and a beautiful night. It is 1 o'clock in the morning, Wednesday morning. You guys have stuck around to have maths done, which is quite phenomenal if you ask me. So it says something about the extraordinary nature that some of you possess, which is great. Thank you so much, and I'll see you again when I see you on the live. And please do make sure to share the channel, share the channel with your friends, with your family members. You have people that you know that may be struggling with mathematics. Share the channel so that they can also have access to joining in the live sessions, and share it also with those that are getting or have gotten paid yesterday being the 15th, so that these people can come here and give me gifts in the live session. I am someone that really loves gifts. It's my love language. It's not just something that's just, I feel loved when I get given gifts. But if there's no gifts given, then I don't feel loved, because that's how I interpret love. Some of you may have a different love language. Some of you may appreciate touch. If you're not touched, you feel like you're not loved. If you're not given words of affirmation, some of you, if you're not affirmed and you are told how great and amazing you are, you are told that you are a phenomenal person, you don't feel loved. So basically, we all have different ways of receiving and ascertaining love as human beings. So for me, live gifts, they show that when I'm doing a live, at least people are appreciating what I'm doing. If there's none, then it means to me, it's like nobody likes me here. People are just here to basically get the free lesson, and that's it. But thank you so much, guys. I hope you have a good one, and I'll see you again when I see you. I hope the lesson was worth it and that you learned something and you gained something. I just want to end on this note. There was someone that basically sent me, I just want to show you something here. In a couple of live sessions back, someone actually forwarded, or let me say commented in the comment section with this message. That surprised me. I just want to remove, sorry, so that you guys can see this message clearly. I want to remove the comments in the comment section so that you can see this message. All right, this is someone that had apparently been joining my live sessions, and I don't know them very well. If you look down there, this is just a screenshot of the message. There's a person called Aiden there, and apparently this is someone who's in grade 11. So I do live sessions as well for grade 11s, and I've been doing live sessions even from the beginning of the year before school started. So apparently this person was joining my live sessions. I didn't even know it, but he joined and he commented and said, "Thank you so much. I watched your lives in term 1 and got 93% in maths. May God bless you." So guys, some of you that join these live sessions, I know you are gaining something from them. Hopefully, my hope is that you are applying these things, and more than just listen to me, that you go and you practice that much more. You use your textbooks, you use your resources, you use past papers, and you dive into the maths, so that what can happen then is that the results can reflect come time when you are at school and so forth. So these live lessons, very invaluable. I appreciate the extension of God's blessings upon my life. So thank you so much as well for that. I hope you guys get my point as to why I showed you that. Okay. Then, without any further ado, let me be off. It was really good. Thank you, and thank you again. Good night.